a box is pushed across a flat horizontal table with an initial velocity v, and it comes to rest after displacement d. Assume that all the kinetic energy of the block is dissipated by friction. Determine the coefficient of kinetic friction. G is acceleration due to gravity. So now you can see that, let's assume this is a flat surface and then this is the box. So this box is going to have a weight which acts downwards, and it is going to have a reaction this way. But we can see that there is this force which is pushing the box, maybe let's assume to the right hand side. And because this force is pushing the box to the right hand side, there is frictional force that acts antagonistic to this box. And because the box is moving, then the frictional force that is acting antagonistic to this box is the kinetic friction. So now, because this box is moving, then kinetic energy is also at work. So what will be the kinetic energy of this box? Now, remember that kinetic energy is equal to half mv squared. But the box only has initial velocity v, so we can calculate the initial kinetic energy, which is equal to half mv squared. Then it comes to rest after displacement d. So it means that the final velocity vf is 0. And since the final velocity is 0, then the final kinetic energy is also 0. Now we know that work done due to kinetic energy is equal to the change in kinetic energy. But because the final kinetic energy is 0, then the change in the work done in this case is just going to be the initial kinetic energy, which is just going to be half mv squared. So let's label this as our first equation, equation 1. So we are done with the kinetic energy. But what is acting contrary to this kinetic energy is the frictional force. Now, this frictional force is the kinetic friction. So what is the kinetic friction? Kinetic friction is given as mu k, which is the coefficient of kinetic friction, then times the normal reaction. Now, this normal reaction is also a force, which is given as mg, the mass times the gravity, acceleration due to gravity. And therefore, you can see that the kinetic friction is going to be mu k mg. Now, what is the work done due to kinetic friction? When the box moved, it made a displacement d. But we know that work done, the concept of work done is equal to the dot product of force and then the force vector and then the displacement vector. But since it was moving in the horizontal direction, then both the force and then the displacement are in the same x direction. So therefore, the kinetic work done due to the kinetic friction is just going to be the kinetic force times the displacement. And in this case, the displacement was d. So it's going to give us mu k mg times d. So let's label this as our second equation, equation 2. So we have, but the question says that assume that all the kinetic energy of the block is dissipated by the friction. It simply means the work done by the kinetic energy is equal to the work done by the friction, since it got dissipated by the friction. So what it means is that equation 1 is equal to equation 2. So it therefore implies that UKMJD is equal to half mv squared. So this is mass and this mass can cancel out because we are talking about the same box. So the mass is equal in both cases. So making the coefficient of kinetic friction the subject, we divide through by GD. So this will give us V squared over 2GD. So if we look through the possible answers, A is V squared D over 2G. It's not A. B is V squared G over D squared. It's not also the case. C is V G over D. That's also wrong. And D is V squared over GD. So you see that the correct answer is answer D. And just for your information, in the next few weeks, I'll be starting a new playlist on physics. And then we are starting with mechanics. We'll be solving a lot of problems in mechanics. And therefore, watch out on my new playlist on physics.